Hello, Honors Geometry students. Today we're going to go through how to find the area of regular polygons. And to refresh our memories, a regular polygon is a polygon where all the sides and all the angles are congruent. And if you take a look, if we want to find the area of a regular polygon, if we know that all of our sides are the same length, then we are cutting this up into a bunch of mini triangles. And then we're essentially just multiplying the area of one of those mini triangles by how many there are. And our formula is 1/2 ASN. And the A is going to represent our apothem, and that's the height of one of those mini triangles. S is the length of each side. And N is your number of sides, so I counted up. In this case, N is 6. So N is how many sides there are. You just have to count it up. All right, so in example number 1, we want to find the area of the hexagon. And again, we're thinking area is equal to 1/2 ASN, apothem, length of each side times number of sides. Some of these things we can grab right away, other things we are going to need to calculate. So the first thing I'm going to notice is that the length of each side is 18, so I'm going to plug that in for S. And if I count them up, I have 1, 2, 3, 4, 5, 6 sides, so N is going to be 6. But my trouble here is how to find the length of my apothem. All right, so I'm assuming here that my hexagon is regular. All right, so I know the length of each side is 18. And since it's a hexagon, remember to find the sum of the angles of a regular polygon, we take 180 times n minus 2. So in this case, it's 180 times 6 minus 2, or 180 times 4, or we have 720 degrees. All right, so that's going to be the sum of all the angles. If I wanted to find the measure of one of my angles inside my regular hexagon, I get divide by 6 and I get 120 degrees for one of these whole angles. And then if I'm going to bisect it, each angle, and there's my kids screaming. All right, and I notice that each of the angles is 60 degrees. And if I take a look at this little mini triangle here, I see a 30, 60, 90 triangle. Remember that across from 30 degrees is x, across from 90 degrees is 2x, and across from 60 is x root 3. So I know that this whole piece is 18, so x has to be half of that, or 9. So my apothem is x times root 3, or 9 times root 3. And I'm going to plug that in for A. All right, so if I plug in, I have 1/2. My apothem is 9 root 3. The length of each side is 18, and my number of sides is 6. From here, I'm going to turn to the calculator because I don't have that off the top of my head. And I have approximately 841.8, and I'm dealing with square centimeters. All right, looking at question number 2. I'm going to find the area of the regular hexagon is 159 square feet. Each side has a length of 18 inches. We want to find the length of the apothem. All right, so area equals 1/2 ASN. We are looking for the length of the apothem, so we are going to solve for A. All right, we know the area is 159, so we'll plug that in here. Apothem's what we're solving for. Each side has a length of 18 inches, so we'll plug that in for S. And our number of sides, we're dealing with a hexagon, so hexagon is 6 sides. All right, so now I'm going to simplify this right-hand side. 1/2 times 18 times 6. If I multiply that all out, I have 81 times A. I'm going to take 159 and divide both sides by 81. And I have that my apothem is approximately 1.96 feet. cruising along then. If I want to find the area of a regular polygon with an 18 centimeter apothem and a perimeter of 217 centimeters. All right. So you'll notice that the apothem is what's given, but I don't know the length of each side and I don't know my number of sides. So I have some sort of figure. I don't know how many sides I have. I know that all of them are congruent, but I know if I add up all of my sides, I'm going to have a perimeter of 217. So my perimeter is 217. If I want to figure out the length of each side, I would divide by how many sides there are. That's n. Hey, my perimeter divided by the number of sides is going to be the length of each side. So I'm going to plug this in for S. So 1/2 times the apothem is 18. The length of each side we don't know exactly, but it's 217 divided by n. And then in my formula, I'm still multiplying by n. Divided by n times n, that's going to simplify to 1. So now my problem is just 1/2 times 18 times 217. Which gives me approximately exactly 1,953, and I'm dealing with square centimeters. So the new formula that we just discovered, okay, so what we typed into our calculator was 1/2, 18 was the apothem, and 217 was the perimeter. So another way to look at the area formula for the regular of a polygon is 1/2 A times P, where A is going to represent our apothem and P represents our perimeter. All right, so now your job is to take a look at section 5-6. You're going to try out problems 1 through 11 and 15 through 18. One last note. Sometimes you're going to come across something that doesn't have that nice 30, 60, 90 pattern. So for example, if you are dealing with a regular pentagon, okay, so regular pentagon, and if I wanted to be able to solve for some sort of measurement in there, it's not a nice little 30, 60, 90 triangle. If I want to find the sum of all the measures of the angles of a regular pentagon, I'm thinking 180 times n minus 2. And then I want to divide by how many sides we have. So 72 degrees is going to be the measure of each angle inside my pentagon. If I cut that in half, I have a 36 degree angle here. And so if I'm dealing with that 36 degree angle, I might think back a couple of units and think about my opposite, my adjacent, and my hypotenuse. So I might be thinking about SOHCAHTOA and set up some of those trig ratios in order to solve for some missing side lengths in that right triangle. So that might help you out with some of those challenge problems. All right, please reach out if you have any questions. I will see you later. Bye.